Hi everybody, I'm Skip Elsheimer. Welcome to the AV Geeks Lunchtime Streaming Show, where we watch old 16mm films, and that was a Coronet film that we scanned that didn't have a soundtrack. Some of the films we run across, they're not made for distribution, but they're kind of a preprint type of thing where they make what they call an answer print, where they're checking levels and quality of the color, and sometimes they just don't have soundtracks. Let's see, what do we got to watch? Wow, all these are biology related for some reason. Just by random. This is Biology in Today's World. Wait a minute, I think we've watched this. Let's try Arteries of Life. Enjoy.
The first 5 links in the chain of life are nature's raw materials, the sun's energy, the chlorophyll in the plant, topsoil, and the organization of the living community. But the chain is not yet complete. Our life depends on the topsoil, but topsoil cannot support life without water. And water itself depends on one more link in our chain, the forest, which store and regulate its flow. This water comes chiefly from the ocean, where it is evaporated and then carried inland by air currents. But these air currents do not distribute this life-giving moisture evenly. For example, in this country, there are many mountain ranges, and the moisture-laden air drifting in from the sea is forced upward when it strikes the mountains. This cools the air, condensing the moisture first into clouds, and then on further cooling, into rain or snow. Thus the air is robbed of its moisture, and there is little left to supply rain in the country beyond. So life in this dry country must depend on water distributed by nature's arteries from the mountain areas. Fortunately, the forests, which cover most mountain slopes, are nature's best collectors of water. Through the ages, the trees add their leaves and trunks to the forest floor, building it into a vast sponge of humus. A single square foot of this humus will absorb nearly 2 gallons of water. A single square mile of this forest can absorb over 50 million gallons of water after one heavy rain or melting snow. Here on the right, we see how forest cover slows the melting of the snow, allowing it time to sink into the humus. On the burned-over slope at the left, the snow melted quickly and was wasted in a runoff flood. On this bare and unprotected ground, the rain washes the finer particles of soil into the crevices between the larger ones, making the surface nearly waterproof, so that much of the water runs off and is lost. But trees and plants protect the surface from this waterproofing action of the raindrops. Their roots rot away, leaving the soil porous. Ants and other burrowing creatures create a maze of small passages that carry the water downward. Here it may spread many miles through the gravel and sand, forming a reservoir, which fills the soil to a level called the water table. From this great underground reservoir, the moisture is carried up again by capillary action to keep the soil moist above it. but plants require an unbelievable amount of water. It takes, for example, nearly 900 pounds of water to raise a single pound of dry alfalfa. And in many parts of the country, there is not enough rain to supply the crop through the dry summer. That is why the land must depend on nature's arteries to properly distribute the water stored up by the reservoirs of the mountain forest 10 miles or 1,000 miles away. This wild land may seem remote and useless to us, but our country could not live without it. Once upon a time, the beaver played a vital part in this distribution system. It has been estimated that there were 60 million beaver in this country when it was first settled. What a tremendous difference it must have made to the country's water supply when these capable dam builders were killed off. Now our own engineers must build huge and costly dams to store water. In desert country, water evaporates very quickly. The water lost by evaporation from this great Elephant Butte reservoir might irrigate many thousands of acres of land now wasted. And besides, silt washing off the eroding hillsides above is fast filling the reservoir. Many miles downstream, we find green, irrigated land next to its desert land that might have been made productive if there had been sufficient water. The dam is certainly a poor and expensive substitute for natural storage. From these far-off snowfields, nature's own great reservoirs, the melting snow seeps into the ground to break forth into 1,000 springs. These flow out to join into brooks, and the brooks combine into rivers. Nature's arteries that keep the soil moist and bring life to the land 1,000 miles away. Here on the Continental Divide, near the mountain peaks, the water from the melting snow may flow east or west. A few pebbles may turn it west to flow 1,000 miles down the Colorado River to irrigate the farms of Southern California. Or turn it east to water the lands of the Mississippi Valley. Or south into the Rio Grande. We will follow it. Here in the fertile San Luis Valley, the irrigated crops depend on an even flow of this stored-up water. Without it, this land would be a desert. But irrigation canals carry it out among the farms, and ditches spread it over the fields. The water that is not used here flows on down the Rio Grande, and hundreds of miles below, it brings new life to the arid land in New Mexico and in Texas. Thus, from the mountain forest in Colorado, the arteries of life flow out to nourish the topsoil in California and Texas. And the soil in the great valley of the Mississippi depends too on this forest, and on the watersheds of the east, and on the condition of the topsoil in all the huge areas between. This raises the question, shall it be fertile farmland? Or shall it be desert dust bowl? Or shall it be buried under floods and filth? The answer lies with the man who uses the forest, the man who drains the marshland, and the man who tills the soil 1,000 miles away. Who shall have the right to decide how that land should be managed? Shall it be the individual owner, or shall it be the people of the nation, whose very lives depend upon the arteries of life?
kind of nice. Some beautiful animation there and color. So behind me I have a film scanner, which has a film on it. We're going to keep with the water thing. This is Fishing 5 Great Lakes. And the color on this is not good. So there you go. I'll change this once I start the film. Change the title once I start the film. Enjoy.
These are the lakes, the big ones, 5 of them, forming a huge inland sea of fresh water stretching across the heartland of the continent. A heartland of fertile plains surrounding the waters of the lakes. A homeland for the millions who live and work near the lakes. Until a generation ago, commercial fishing was one of the big attractions around here, and a lot of people made their living from it. Things have changed since then, but some of the more persistent ones are still trying to earn a living catching fish. In the Saginaw Bay area of Lake Huron, they go on setting shallow trap nets, but catches have become as unpredictable as the lake weather. They're still getting yellow perch, northern pike, carp, and catfish, but their catches are smaller, and they have to work a lot harder to get them. And they work a lot longer, too. On Lake Huron, they still go after whitefish using deep traps. These are about the best of the lake fish left, and so bring a good price, if you can find them. No matter how small the catch, the undersized ones go back. That's the law. Plenty of ice keeps the fish fresh. Off Ashland, Wisconsin, on Lake Superior, they do their fishing just offshore. They're using a pound net, a type of trap. A variety of mighty good fish are taken out of the cold, clean waters of these northern lakes. They have to be sorted for market. It's a different lake. The gear is similar, but the problem is the same. Not enough fish to make it pay. Lake Ontario has never had much commercial fishing, but now there's less than ever. They're using pike nets. Don't ask me why they still use this old gear. Maybe they figure the fish are used to it by now. You won't catch many fish with pike nets, but then there aren't many fish left. The states are trying to improve the fishing. Size limits are set and the seasons are regulated, but the fishing hasn't shown much improvement. Well, the fish are changing. How about the people? This is Catfish Kate. Now, I wouldn't say she's a typical fisherman, but she can outfish most men. She works out of Bayport on Lake Huron. Kate's husband is the skipper of a fishing boat, but with things the way they are, she has to help out. Her gear is a variation of the old hook and line. These trot lines can have hundreds of hooks. It's good gear for catfish because they get to be pretty big. They're not the prettiest fish, but they're mighty good eating. Kate can pull and set 1,000 hooks a day, and she has to these days just to make a few dollars over expenses. But it's a healthy life. Even the old reliable beach seine isn't producing the catches it once did. About a mile of net is towed out into the lake and then hauled back. Erie is a shallow lake, so this kind of gear works fine. A beach seine costs plenty. Nowadays, it takes hard work and luck just to cover overhead and labor. Not only are the catches smaller, but they're usually made up of fish that can be used only for animal feed or industrial products. Many beach seines are family operations that have been handed down from generation to generation. But unless they can be made to pay, the fishermen will quit and the valuable beachfront property will be handed over to other interests. The time is early winter. The place is Grand Marais, Minnesota, on the far side of Lake Superior. And it's cold here. They have to be hardy, almost foolhardy, to fish in this kind of weather. But they do. They don't have any choice if they're after Lake Herring, because this is when the herring run. They're using gill nets. A lot of fishermen on the lakes use gill nets. Their fathers and their grandfathers used them, and I guess you could say that gill nets have become sort of a tradition. And it's one tradition that calls for a lot of work. The fish get tangled in the net, and each one has to be worked free by hand. This takes time, lots of time. They're getting lake herring, but even a good catch of lake herring won't pay for this kind of work. Don't get the idea that we haven't improved any of our fishing methods. After all, we developed the gill net tug. It's not only got a roof and sides to protect the men from the weather, but also a mechanical lifter to haul the net. The only trouble is we haven't figured out an easy way to get the fish out of the net, so we still have to take them out by hand. But nobody's really worried about this, because we still haven't found a way to get enough fish in the net. You need money fish to make gill netting pay. Fish like lake trout, walleye, and whitefish. But these fish are getting harder to find, even in places like Isle Royale and Lake Superior. This area used to be loaded with lake trout hotspots. Now, even the sportsman has to do a lot of traveling to find them. But for the man who has to make a living, well, you can see for yourself. If the sports fisherman knows the spots and has what it takes, he can still land a good catch. They may not be as large or as plentiful as they used to be, but there's enough to keep him interested. Years ago, he didn't brag about anything under 10 pounds, and 30-pounders were common. The sea lamprey is the main reason for the disappearance of the lake trout. It may look like an eel, but it isn't one, and it doesn't act like one. Once this vicious, beady-eyed monster attaches itself, hardly ever can the fish shake it off. It feeds like a vampire, with its sucker-like mouth locked onto its victim. Its horny teeth and rasping tongue cut through the scales and skin to get at the blood and other body fluids. It usually doesn't stop feeding until its victim is lifeless. And the sad part of all this is that the lamprey doesn't belong in the lakes. It's a sea creature that got into the lakes by way of the Welland Canal, and then spread into the upper lakes where it multiplied, feeding on the big trout. And when these began to get scarce, it started on the large chubs and whitefish. The smelt, like the lamprey, is another foreigner in the lakes. Some fish may be disappearing, but there's certainly no shortage of smelt, particularly in Lake Michigan. Each year, we get more and more of them. Maybe this is another sign the lakes are changing. In the spring, most of the lakes are swarming with these pretty little fish, and you can catch all you want. The big job is to get a decent price for them. Even when the lakes are frozen, you can still get smelt. Just set your net under the ice a few miles offshore, and then go out, cut ice, and haul net in sub-zero weather. With smelt come troubles. When they're running, the fishermen bring in so many that the market is glutted. But even when they're not running, smelt aren't easy to sell. Many people don't appreciate these tasty little fish. In the spring, when the smelt are running, you can catch them at night, too, and everyone joins in. 50 years ago, there wasn't a smelt in the lakes. Then someone got the idea of trying to stock the lakes with Atlantic salmon. They brought the smelt from Maine to serve as food for the salmon. The salmon didn't take, but the smelt did. And today, they're one of the most plentiful fish in the lakes. So plentiful, in fact, that some fishermen have begun to worry. Neither the lamprey nor the smelt would be here if we hadn't helped. And it makes you wonder how many other problems man brought to the lakes. I guess it started when we began clearing the land around the lakes. There was plenty of timber, and we cut it and used it. We burned a lot, too. We got rid of the trees, all right. and changed millions of acres of watershed. Then we started on the land, plowing under the grass to make the fields productive. Productive and bare and unprotected. The wind, the rain, and the melting snows did the rest. And millions of tons of topsoil flowed into the lakes, changing depths, lifting water temperatures, and covering the life on the bottoms. On the surface, the lakes looked the same as ever, and few noticed the changes. But there were plenty of changes, and soon you couldn't help noticing them. Towns and cities grew and spread and spilled out over the whole region. Houses everywhere. And before we knew it, we had almost half the people of the country living here. Living and playing here. And the beautiful lakes make a perfect playground. They come from all over the country. There's always plenty to do. And if you just want to relax, there's always fishing. And this recreation is important to millions, whether they're angling for smallmouth bass in Green Bay, walleyes in Bay de Noc, herring at St. Ignace, or muskies in Lake St. Clair. All this is in jeopardy. Fewer fish for sports fishermen, fewer fish for commercial fishermen. There were other changes too, as we went on to find other uses for the lakes and the land around them. Materials, markets, and labor were here, and so we started putting up plants and factories, plants to generate power and plants to use it. Mills for smelting ore and turning out steel, and mills to use it. Factories for all the products people need, and a lot they don't need, with the lake supplying millions of gallons of fresh water to quench the great industrial thirst, and for a waterway to boot. Put all of this together, and over the years it adds up to a lot of wear and tear on the lakes, enough to take a lot out of them. But judging from the looks of the lakes in some areas, we were also dumping a lot back in. Sewage, chemicals, industrial wastes, and just plain garbage. Maybe it doesn't look like much, but it pours in and it adds up. Sometimes you could see it, often you could smell it. And now and then, you'd see the results. But the fish weren't the only ones affected by all these changes. The fishermen were the first to suffer. And in many fishing towns, ghostly relics are all that's left. You had to be an optimist to try to sell a fishing boat. And as for a fish processing plant, what would anyone do with it? And if you're patient and have the time, you can hope and wait for the fish to come back. A lot of fishermen are still waiting and working at other jobs to pay the bills. For most of them, the change was gradual, with more and more time spent on outside work as fishing earnings dropped. But even with full-time jobs, the hard-headed ones go on fishing. Others go on fishing because they have no choice. They spent their whole lives working with boats and nets, and they're too old for change. Fishing is all they know, so they go on with their work, supporting themselves as best they can, waiting for the big fish to come back. and talking about the old days. It's hard for the young ones to believe the stories they hear, stories of large catches and of enormous trout. Among themselves, the old-timers still ask, what happened? And they recall strange things they've never been able to explain. Were these warnings? Today they all complain about the changes, but they can't agree on what caused them. But the big question is not what happened, but what's going to happen. One thing is certain, a lot has to happen if commercial and sports fishing on the lakes is to improve or even survive. And it has started to happen. With the backing of the states around the lakes, the federal government and Canada, the fishermen are trying new methods. One they're testing is the trawl, and some states have issued special authorization so that this gear can be used on an experimental basis. The big advantage of trawling is that it eliminates a lot of the handwork required by the older methods and provides an economical way of taking the lower-priced fish. A single trawler can catch large quantities of fish with very little hand labor. And because the trawl can be fished selectively in the kinds of fish it catches, its use promotes the growth of desirable fish by removing those that are overcrowding the lakes. Trawling helps maintain a balance beneficial to both commercial fishermen and sports fishermen. While most of these fish are not sold now for human consumption, they can be used for a variety of products, and experts are convinced that with the right kind of gear, the handling of these underutilized fish can be made into a profitable operation. Mink farms are already using some of this fish, and they'll probably be using a lot more. There are many fur farms near the lakes, and they have become big year-round markets for underutilized lake fish. And even larger quantities can be used by manufacturers of pet food for shipment to all parts of the country. Technologists are trying to broaden the market for lake fish by finding new uses for them. They found that the fish are rich in food elements and can be used in many new ways. The lakes themselves are being studied, and the Bureau of Commercial Fisheries keeps floating laboratories moving around the lakes, learning about the movements of the fish, their feeding habits, and other valuable information which is passed on to help sports fishermen as well as commercial fishermen. For some time now, government, with the help of industry, has been working to control the lamprey, and they've found a method. They wait until the lamprey come into the streams to spawn, and then destroy their larvae. It took years to find chemicals that would kill the lamprey larvae without harming the fish, but they finally came up with the right combination. And it works. All those young ones are dead, but there are still plenty of those wily monsters getting into the lakes, and it's going to be hard to get rid of them. In the meantime, the United States and Canada go on stocking the lakes, stocking them with lake trout. Hatcheries are also experimenting with other fish that might be able to live in the special environment of the various lakes. We are also trying to develop bigger markets for the fish we have. With the bones out, fish are easier to eat and easier to sell. That's why we freeze some of the fish, because then we'll be able to sell them all year and all over the country. We've never canned much of our lake fish, but we're seriously thinking about doing it now. This would be a way to have a year-round market. Smoked fish have been a delicacy to folks around the lakes for years, but there are a lot of people all over the country who have never tried it. It's our fault, and we're trying to correct it. If we're successful, we'll broaden the market. One reason more people don't eat our Great Lakes fish is that they don't know about them, and we're taking care of that too. We're telling and showing them every way we know. Schools and other public institutions can become big users of lake fish. They need healthful food. And when it comes to nutrition, you can't beat fish. You can't beat them for taste either. And speaking of taste, we've never had to do much promoting of our lake fish in the good restaurants. Some of them built their reputations on lake trout and whitefish and have special ways of preparing them. We're encouraging restaurants to go to work on some of our other fish. And in spite of our troubles, we still have a fair variety of them. We've got the variety all right. In fact, things are beginning to look brighter for those who look to the lakes for recreation or for a way to earn a living. The lakes have changed, and they're still changing. But now we're learning to change with them. And with all we're doing, all we plan to do, things are bound to get better for everyone using this great natural resource. The lakes we have today are not the lakes of 200 years ago, or even 50 years ago. But they're still the Great Lakes, and when all the results are in, they will be greater than ever.
Wow, that was fascinating to see him vacillate between things are great and things are horrible. It's like, oh yeah, they're out fishing using this type of net. Unfortunately, there's not enough fish. And then talking about why there's not enough fish, and then, oh, here's wonderful leisure activities and how the other ways the Great Lakes contribute to our country as far as resources and enjoyment, etc. But then there's lampreys, and then there's this, and and pollution. Yikes. But fascinating nonetheless. And that film was beet red. It was very, very red. So I tried to tweak the colors a little bit. One last film. We talked about how much fish serve humanity. What about bacteria? Have you ever thought about that? Here's bacteria serving humanity. Enjoy.
Events of the past and present tomorrow. For our future depends on you. To untangle today's problems, we need to understand yesterday. We hope this film series will make you aware of the people, places, and events which have helped shape our nation and our world. Manufacturers Hanover is pleased to sponsor this educational film as a special service to schools in the New York City area.
Our journey begins in what seems like another world, a black abyss, what is actually the bottom of the ocean. At these depths, the seabed is dead and barren, with few exceptions. This living oasis exists in water warmed by heat streaming from volcanic rifts. These plants get their energy not from sunlight, but from bacteria that break down the explosive gases at the edge of creation. This strange lost world exists only because of clouds of single small cells, bacteria. But while these cells are primitive life forms, they are also the seeds of death, destruction, and regeneration. Scientists are now perfecting new ways to grow and cultivate cells far beyond nature's boundaries. It's a curious new science called biotechnology. These astonishing cells are the simplest form of life on Earth, with only one goal: to reproduce. Remarkable as it may seem, some bacteria can double every 20 minutes. In 2 days, a clean handprint has grown colonies like this. Though simple, they are extremely diverse. Without bacteria, we couldn't have foods like cheese or tofu. Digesting food would be impossible. These bacteria, referred to as bugs, belong to a family of cells which are nature's catalysts. Each bug is a factory, producing substances which literally transform matter. Without bacteria, nothing could decay, and the earth would be inundated with garbage. They have the magical powers of decomposing every frozen leaf into next summer's flowers. No one understands better than a farmer the way bacteria break down waste. And this farm takes advantage of them more than most. What looks like a factory is in fact a pig farm. Mass producing this much pork creates up to 30 tons of insoluble waste per day. This is where the exploitation of the bacteria begins. Find one that breaks down the slurry into something useful, put it in a tank, and keep it well fed. This bug is a particularly clever chemist. As it breaks down waste, it releases huge bubbles of gas that can now be converted into energy to run an engine, producing 22 kilowatts of continuous electricity, enough for lighting and heating the pig farm. Utilization of this gas as a source of energy rids the waste of the foul odor that comes out of the tank. What remains is a liquid fertilizer, free from harmful bacteria, which can be used to feed the fields. But it is the solids left behind that have the most surprising potential. They are still full of bacteria, ready to do another job. Each cell is a microscopic blob of pure protein, and there's enough protein in this sediment to feed all of the livestock. Mixing barley in with it makes it more palatable. Grow more of the tiny cells and they could actually replace expensive animal feed altogether, because they contain as much protein as soybeans or fish meal. As easy as this sounds, we are still faced with one problem. In order for bacteria to breed, they need a large area to grow. Scientists found the answer in a seemingly common household item, the sponge. The sponge is a perfect nesting area because the bacteria settles into the empty spaces and becomes densely packed. The minute sponges in this sludge contain millions of cells. Sewage treatment centers have used bacteria cells to break down waste for years. But until now, these cells have needed so much elbow room, it has taken 25 beds like this to clean up the pollution from one small town. Pack the beds with sponges of bacteria, and you can make 5 of them do the work of 25. Bacteria in the sponges not only break down old materials, they also manufacture new ones, as we will see in this next experiment. Here, biotechnologists have actually used sponges to harvest a crop from a cluster of plant cells. The essence of a plant is concentrated in its cells, but as they grow, they waste a lot of energy making roots, shoots, and flowers. Nature takes time, and after a year, just a tiny part of the plant yields the substance we want. Saffron, for example, is painstakingly collected by hand, picking the stigmas out of the crocuses. And chili is produced in just one place, the fruit, commonly called a pod. There's nothing new about growing plant cells in the laboratory. Scientists have been doing it for years. Now biotechnologists are growing only what they need in shorter periods of time, extracting the useful essence of the plant directly from its cells. Handled skillfully, a minute piece of stem from a chili plant will sprout into an island of cells. A quick way to grow more from this glistening knot is to mass produce them in liquid using sponges. With an electron microscope, we can see them forming groups as thick as bunches of grapes. Gently transferred to the right environment, the captive cells in their sponge prisons are easy to control. Within this column there are 1,000 chilies, yet not one of them has a pod. Fed stimulants, the cells start manufacturing far more flavor than a field full of plants. This is the prototype for a continuous production cycle, offering convincing proof that sponges could be the key to harvesting many sought-after plant substances. Chili is not only used to flavor a meal, it is also an important ingredient in medical ointments. Even a plant like the common periwinkle produces 2 anti-cancer compounds worth $3,000 a gram. The job of scientists is to constantly improve on what bacteria do naturally. To begin, one must study the inner workshop of the bacteria cell, the DNA. This circle of DNA, the plasmid, contains the blueprints for everything the bug does. By clipping out sections and replacing them with new ones, you can get bacteria to make something not for themselves, but for us. They can produce all sorts of substances, like insulin, which is obtained from the pancreas of animals such as pigs. And bacteria breed fast enough to be able to mass produce the things we tell them to. Inside this icy vault are unnatural cells, artificially bred by biotechnologists, tinkering with their structure and manipulating their lifestyle. Under this microscope is just one cell they have successfully adapted. It makes granules of materials called PHB, similar to the way our bodies produce fat, but PHB can be turned into plastic. Researchers mixed 100 different blends of starch, sugar, and gases to persuade the cells to produce bigger and better granules. Trays full of inexpensive food samples were sterilized before the bacteria was added. Once the precise recipe was discovered, they scaled up production in what looks like a brewery of stainless steel vats. Adding buckets full of sugar and the right combination of temperature and conditions, the bacteria will increase 1,000-fold. This steel fortress protects the bacteria from the outside world. The cells need nurturing and constant monitoring, but soon the sacks full of junk food will turn into sacks full of biodegradable plastic. A plastic ideal for medical purposes because it's compatible with living tissue. A plastic which will solve a waste disposal problem, decomposing with time. The sticky halo oozing from this microbe may one day change the oil industry. By adding a bacteria that thickens water, the oil fields can produce more. Unlike expensive man-made chemicals, the sticky substance won't disintegrate when pumped between the pores of rock or sand. With water, you are lucky to retrieve 40% of the oil. Bacteria make the job much more efficient. By adding a surfactant, a shampoo-like substance also made from bacteria, it is possible to loosen and extract oil from almost anywhere. Inside every bacteria is a microscopic powerhouse. By connecting the powerhouse to an electrode and attaching the electrode to a motor, you can produce enough energy to lift a small load. Given time, we will even combine biotechnology and advanced electronics. This boy is a diabetic. A biochip placed in the wall of his vein senses his need for insulin. Once stimulated, insulin is released, allowing this young man and others like him to lead more normal lives. Scientists will continue to study bacteria as they present astounding opportunities for scientific breakthroughs in medicine and environmental problems.
The Science Screen Report has been presented to you as a community service of Manufacturers Hanover.
Thank you, Manufacturers Hanover, for that fine kinescope film about how we manipulate bacteria to help us. I'm sure there's a lot more of that happening nowadays, for the good and for the bad. But yeah, today was all biology stuff, just randomly. Yeah, join us tomorrow. We'll watch some more films. I seem a little out of it right now. I rode my bike to work, and maybe that's throwing me off, like breathing in all that pollen. I'm in a pollen daze. Anyhow, join us tomorrow. And if you like what you saw, hit the thumbs up, hit the like button, subscribe. These are all great ways to support us, and share what we're doing. Tell other people that you think might like what we do on your social media, etc. I gotta say that I don't know what happened, but somehow my YouTube ad revenue is slowly bouncing up, and I have no idea why. I don't know why it was going down, but it's beginning to go back up. And so you can watch films that we've been posting. We've been posting a lot of stuff. Some of the things we've been showing on our streaming show, but some other things that you haven't seen. So, and some of them are in better quality than what we showed, because when we're showing them, I'm doing kind of a on-the-fly color correction, and the tools in OBS are not as good as the tools in post on Resolve, which is what we use to capture the film. So sometimes the quality of the image looks a lot better, and if you're like, oh yeah, I want to see that film again, or I want to send a link to it, there's a great way to do that. But anyhow, everybody have a great rest of your Tuesday, and we'll see you soon. Rick Hay, I'm glad that you were not negatively affected by the bridge calamity, tragedy that happened. It was horrible. There's going to be more of that happening, unfortunately, because stuff like that happens. Yeah, everybody take care. Be good to yourself. Be good to your friends, family. Reach out, say hi.